Here we have Rita and Jason. Welcome.
Thank you. Thank you.
Huh?
Hello. Who's got hear us? Yep.
Hello. All right, while these nice folks set this thing up, I love this crowd. So if you guys don't mind, I love taking selfies. So I'm going to take a selfie of everyone, so please smile for Twitter. Come on. Woo! All right, good looking.
Thank you.
All right. All right, so maybe
we can just introduce ourselves.
Kick it off. So my name's Rita Zhang. I'm an open source software engineer from Microsoft. I just flew in from San Francisco about a day ago, and this is my lovely colleague, Jason Poon. So Jason flew in from Seattle, and we are very, very happy to be here. This is our very first time in Greece. So very happy and very, very welcoming hospitality.
Everyone's been so friendly. The weather's been so nice. It's a nice change from the rainy weather of Seattle. So having to see this giant orange thing is kind of a relief. So as Rita mentioned, we are open source engineers, and kind of why we do, it's kind of a revelation. Like Microsoft as of if you imagine Microsoft 5 years ago, it's kind of crazy that we, open source engineers, exist within the company. And so a lot has changed within Microsoft. And so one of the things that Satya Nadella, our new CEO, has tried to do is that we want Microsoft platforms and tools to run well everywhere and anywhere. And that includes just any tooling that our partners and customers uses. So we have first-party support for Node.js. Rita's going to talk about SaltStack. And yeah, that's kind of why we do the work we do.
Great. As Jason just mentioned, what does it mean when we say Microsoft does open source, right? So how many of you guys are kind of surprised? Let's be honest. All right, cool. I remember when I first got this job, it was like, okay, so this girl is coming on stage, and she's presenting in a Mac laptop, and she's talking about open source, like, are pigs flying, right? So essentially, maybe you guys don't know this, or maybe you know, Microsoft is actually one of the biggest contributors to open source. So how many of you guys use Docker containers? Or VS Code? .NET Core? All right, so all of these solutions are open source, and Microsoft is one of the top contributors to a lot of these open source projects. So what we do at Microsoft, specifically our team, is we work very closely with open source communities to bring support and features to all of you folks, and making sure that you have a good developer experience. So what that means is a lot of us have to, we partner with startups and enterprises and making sure that we unblock issues that they have. I'm sure a lot of you guys are running on a cloud, either a public cloud or on-premises environment, where you're trying to use the latest, greatest tools out there, and you really don't want to be bothered with which public cloud am I running on, right? So because of this is why we work with nice folks like you guys, and we go on GitHub and we search for issues and really look at where our developers and companies blocked on, and this is where we go in and we fix issues. So what this talk is about is we worked with a open source community called SaltStack. How many of you guys have heard of it? Okay, and how many of you guys are infrastructure folks? Okay, great. So we worked with them actually to partner with a startup called LogDNA. So LogDNA is a startup that focuses on streaming logs for your applications. And they're a Y Combinator company that's based out of San Francisco. And when we initially worked with them, we want to make sure that we can actually take what they currently run on AWS and be able to run everything they currently have on Azure. So they're avid users of SaltStack. This is where they write infrastructure as code, and they deploy everything and write everything as as code and scripts, much like you write for front-end applications, right? The only difference is you manage all of this stuff with code, and you really shouldn't be bothered with, am I running on AWS, am I running on Google, or am I running on DigitalOcean, or maybe Azure, right? So this is exactly why we partner with them, because we want to make sure they have a smooth transition to Azure. So what we're going to talk about today in this session is how we help them and how we partner with SaltStack open source community to actually bring Azure support for this open source community, and so that developers like yourselves can actually utilize SaltStack. And we're also going to talk about specifics like what is SaltStack, right? And why is this relevant to you? This is more for the infrastructure folks in the house. I don't know, how many of you guys actually manage infrastructure for your company? Okay, this is definitely for you. And I just want to say thank you for doing the awesome work that you do. And we all know infrastructure is very, very hard, right? And this solution is supposed to help you with that. Wow.
All right, now where were we?
It's like everything that could possibly go wrong just happened. All right, so anyway, so as I was saying, we're open source engineers from Microsoft, and let's advance to the, yes. Okay, so at the end of this session, we hope that you'll walk away with what is SaltStack and what it can do for you, and specifically, how does it work on Azure? We're going to talk about the case study that like the partnership that we did with LogDNA and how we added supports for Azure to SaltStack. And at the end, we're going to see some cool demos. So with that.
Cool. So infrastructure. I think during that downtime, a couple people raised their hands of like how many people do infrastructure. And it's really work that people don't appreciate, but it's really difficult. And just because of this kind of list. The infrastructure is complicated. There's hardware you need to provision. How do you set up your virtual networks? Once you have those machines, how do you then install Ubuntu or CentOS or Windows or whatever your operating system is and manage updates? Like we had that what was that? Yeah, that exploit that just happened. How do you update and make sure that your servers are not susceptible to that issue? Then there's scheduled tasks. So let's say you built an awesome application, Trivago, for instance, and you need to deploy on this machine, right? So once you deploy on this machine, there's all these mundane tasks you need to maintain. Like how do you do log rotation? Once your log drive fills up, how do you get those logs off that machine and into like your indexer? Certificate renewal. So if you're using something like Let's Encrypt, you have to renew your cycles very frequently. So these are stuff that you always need to maintain. Next is kind of manual tasks. So once you put it on a machine, there's always these things that you need to manage. And so this is completely doable if you have one machine. Like, does anybody here have their services running on like 1 or 2 machines? Yeah, exactly. Be honest. It's cool. Like when I first joined Microsoft, I joined the Windows Store team, and we had 2 giant, beefy machines, and that was the Windows Store running on them. So it's completely okay if you have just 1 or 2 machines. And in that sense, you can very easily just SSH into the machine or RDP into the machine and maintain it. But how do you then scale it from 2 machines to 5 to 10 to 1,000? So like, let's say your website, your app hits the Reddit effect, or it goes top on Hacker News. Then you need to all of a sudden scale to this many machines. How do you make sure that everything we just did is the way we did it for the first 2 machines?
Cool. Now, I know I just asked a lot of you if you're infrastructure folks, but how many of you guys actually gotten like phone calls or texts that like, oh, my app is down, or I can't reach my services, my VM is not coming up? How many of you guys have gone through that? Well, we want to avoid that, right? We want to make sure this doesn't happen. And I know a lot of us could be like, oh, I figured out how to do this last time, so in the future, I'm just going to try to reproduce what I just did. But how many of you guys actually did like, oh, shit, what did I do last time? Like, I know I have this problem. And so the idea behind infrastructure as code is that you don't have that problem. Next slide, please. So what infrastructure as code is, it allows us to make sure that we manage our infrastructure as code. So that just like how we write applications and services, we basically version control all of our scripts so that we know exactly what we did last time at 3 o'clock in the morning, right? And when we apply a patch, we know the order that we applied it in, and we do this in the same manner across all of our nodes, right? So it creates a more repeatable solution. So what we have here, as we just defined that infrastructure is hard, what we want to do is when you're actually creating hardware and networking, this is where all of the cloud providers have their own solutions. So I know some of you guys are probably running AWS. So Azure has its own ARM template solution, which is much like AWS CloudFormation. So it allows you to basically, again, write infrastructure as code so that you can define exactly what type of VM you want, storage, what type of disk, how you attach this, network, VNet, subnets, right? So all of that wonderful infrastructure things that you can script. And that's where Azure ARM template comes in, and we'll give you guys a quick demo in a bit. And next, as Jason mentioned earlier, when you're running distributed software, a lot of times you're not dealing with one single VM, right? Usually you have a master-slave relationship, and your slave and even master, sometimes you can have one to many, right? And so when you have that kind of architecture, you tend to need a solution that allows you to create VMs on demand, right? And that's where Salt Cloud comes in. So Salt Cloud is a component within SaltStack that allows you to kind of abstract a layer of all the cloud that you're actually deploying your VMs to. So this actually abstracts the public cloud APIs for you so that you can basically provision new nodes in exactly the same manner. Next, we have at the operating level and the scripts that you run to deploy your binaries, the patches, the jobs. So you can define all of that with SaltStack, and we'll go into it a little bit.
So the one takeaway I would say with this slide is we version our code. Like, if you are not using Git, you are insane. And so the same principle applies with versioning your infrastructure. And that's the whole intention with infrastructure as code. So you should start versioning your infrastructure. And the way to do that, which we'll demo, is, as Rita said, Azure ARM templates, Salt Cloud, and SaltStack. But there's all these other different tools that you can leverage, like Puppet, Chef, or CloudFormation templates. But let's kind of dig into what SaltStack is. So SaltStack is an open source project. So it's completely free for you to use, but it is also backed by a commercial company if you want enterprise level support. And it's really popular on GitHub. So this is kind of a screenshot of the number of stars and forks that it has. So it has a really good community as well, a really good backing community, very active, and it's completely and wholly developed in the open source. So not only is the code open sourced, but the company behind the product, SaltStack, also leverages the whole GitHub development flow. So they use issues to track their issues, PRs and releases and so forth. So you get a lot of transparency to kind of the progress of the project.
And the project currently has over 1,800 contributors, and yours truly over here have added support to Azure. So again, because it's on GitHub, all of you guys can try it, and if you have issues, you can report it, and the nice folks like us can go fix it. Like we said earlier, I just want to highlight that it not only works for public cloud, but also on-premises infrastructure where you're running with a hypervisor. So it also works for that scenario. So earlier we were talking to the folks from IntraSoftware. There's a lot of enterprises out there that are kind of maybe a little bit hesitant to go to public cloud. So this is also something that they can use in their own private data center as long as they're using a hypervisor. So really quickly, the history of SaltStack. So I Literally stole this slide from SaltConf 2015. So it was founded originally in 2011. It was created by Thomas Hash. He basically created it as a personal project, and then he put it out there for people to utilize. And LinkedIn really liked it, so they then start supporting it and asking for features. And then the community just grew, right, like wildfire. And so currently, a lot of the enterprises are also using it, but is probably more popular among the startups, I would say. Anything you want to?
So we've kind of talked about, at a high level, what the problem is and what SaltStack is trying to solve. Let's kind of dig into the behind the scenes of what the architecture behind Salt Cloud is. So this is kind of just introducing a bit of the nomenclature for SaltStack. And it is kind of a master-slave relationship. So you have a Salt master, and that controls a several set of minions. So you can have one minion to many. And your master itself can also be a minion, so you can control yourself. Next, we have kind of execution modules and formulas. So a sample of an execution module is kind of the command you see there. So salt star disk usage, and this is a way in which, as a master, I can execute that command. And for all the minions that are under the master's control, I can get the disk usage for 1 VM or 1 million, for instance. The disk usage is one example of the execution module that SaltStack provides, but there's several other modules that are out there, so you can very easily query for CPU memory, disk usages, for instance. The next, which is formulas. So we're going to walk through a lot of this in our demo, but just kind of give you a high level of what it is. A formula is the state at which I want to apply to a certain machine. For instance, I am a heavy Vim user, and I cannot function on a machine that does not have Vim. So I could define a state called Vim and apply it to all my VMs, and SaltStack will make sure that Vim is installed on every single machine. So what we'll walk through shortly is kind of installing ElasticSearch and MySQL as different states. Next, we have grains. So you can think of grains as kind of a key value data store. And it's really a way to distinguish a set of minions. So you could have different minions having different metadata. So you could have a minion that is Ubuntu, and another minion that is CentOS, another minion that's Windows. And you can define all that information in grains. So you can use grains to target specific machines. So say I only want Vim installed on my Linux machines, or just on my Windows machines, and I can do that using grains. Next, we have a top file. So with formulas just define kind of the applications that I want to deploy. For instance, MySQL or Elasticsearch. A top file is kind of the overarching, this is my whole deployment, and I want these 10 machines to be Elastic, and these 2 machines to be MySQL, and then these other machines to be something else. So a top file is really just how you define the state of your cluster overall. Next, we have the Salt Cloud. So Salt Cloud, as Rita mentioned, is an abstraction by SaltStack, in which case you can provision VMs in AWS, Azure, EC2, and so forth, just through the Salt APIs. And I think we can probably go to the Salt webpage. Oh yeah, we restarted this machine. Actually, it's all loaded. But this is the documentation for SaltStack, or wait, you're not seeing it, I see.
We're not seeing it? Oh no.
Oh, this is scary. I don't want to get out of here. Let's just leave it as is. But if you go to the SaltStack, the documentation, there's like a giant list of all the Salt clouds that it supports, and it's like believe you can just trust me. It's like 30 cloud providers long, so it supports all the major ones plus like Linode and all the OpenStack and stuff like that. So it's a way in which you can abstract. At which point you don't really care what cloud you're working on. All you need to deal with at that point is SaltStack. And that's the intention of Salt Cloud. Did we break it?
Okay, well, we're going to go to the demo part, so it's going to be interesting. Okay, so basically, as we mentioned, right, you can deploy a lot of the really common applications or solutions into your environment with SaltStack. So quickly, we're going to demonstrate ElasticSearch, and then at the end, Jason's going to walk you through how to deploy MySQL. But there's a bunch of formulas that's already on SaltStack's GitHub repo in a way that you can basically just git clone a particular formula and then use it in your SaltStack cluster. So for this particular demo, I'm going to walk you through how I deploy Elasticsearch. So really quickly, just kind of walk you through what the solution is doing. Can you guys actually see that? OK, cool. So first, we are using Azure ARM template, which is a JSON format description. It describes to Azure what resources you need for your particular solution. So what we did here is with an ARM template, again, it's just a JSON file that basically describes I want a VM that I need to run SaltMaster. And I need a public IP and open up certain ports so that I can actually reach the VM from outside. And then I also need storage accounts to save all my disks, data and OS disks. And also I need virtual network to make sure all of the minions can actually talk to the master and all the minions can talk to each other. And last but not least, network security group, so that I can actually open up certain ports for my particular need. So for example, for Elasticsearch, everything runs off 92.0.0, so I need to be able to open that up so that my other applications can actually reach Elasticsearch. So that's what Azure ARM template does. Now, once I have that, as a post-deployment aspect of Azure ARM template, you can actually tell ARM template to run some scripts at the end. And what we're doing is I'm just triggering off a script that allows me to run this bootstrap shell script that is provided by SaltStack. What does it do? It's essentially something, again, you guys can find it on GitHub, but it deploys, pulls down and deploys all the binaries that you need on the SaltMaster so that you can just run your Salt commands, and then it's able to understand all the configurations on the master. And with those commands, what you do next is basically we will run Salt Cloud. So with Salt Cloud, I can tell the SaltMaster, now go and create 3 VMs for me, right? And go and deploy these things there. So what Salt Cloud is doing right now is actually looking at the Azure configurations for Azure Cloud, so that when you run Salt Cloud, create these VMs, it actually understands, oh, you want a VM of certain size, and you want it in this location, and you want it in this data center, right? So once I run that, then it creates 3 VMs for my Elasticsearch cluster. And once I've done that, then here's where I run Salt State High State, which is basically a way for us to tell Salt, now go ahead and apply all the changes to the nodes that I specify, so that you can install all the binaries and run all the scripts to spin up my Elasticsearch cluster. And what that means is install things on Elastic Master, because the master is different from the slave, and install certain configurations on the slave so that the slave can actually talk to the master. And I'll show you that in a bit, like what the exact configuration looks like. So yeah, so that's basically the flow of to start off the deployment. And at the end of this script, once it's done executing, you basically get all these VMs, and you get the Elastic Master and the slaves all up and running, and you just get an endpoint. And with the endpoint, you can point your applications to your Elasticsearch index. OK, so before we actually get into the VM, as we mentioned, Salt Cloud, right? So what does it actually look like? So when you run Salt Cloud, the CLI, it basically goes into SaltMaster and looks for these files, right? So these are configurations. This is a nested and inherited nested structure that basically tells SaltMaster, hey, here's all my cloud providers, and here's all the configurations for each cloud provider, and that sits in the etc salt cloud provider folder. And then once you have all the providers' information, such as your keys and client secrets to your Azure subscription or AWS subscription, and then another folder that basically provides all the profiles for the type of VM that you want to create. So like I mentioned earlier, you can actually create configs that will tell Salt Cloud, I want to create a CentOS operating system, or I want to create Ubuntu VM, and I want to create with certain size or certain CPU and memory utilization. Okay, so here's where we're going to see if this actually, our reboot is working or not. Wow.
You got a mirror.
It can't see anything, huh? Oh my God, why is this doing that? What the Oh, I see.
Oh, it's over there. So you have to.
Oh my God.
But while Rita kind of sets that up, does anyone have any questions?
Everything good?
No.
What do you want to do?
We just want a mirror.
Hold on.
But while Rita sets that up, does anyone have kind of questions before we hit into code? Because like as soon as we hit into code, it gets kind of,
all right.
There's no more pictures. So it's SaltStack, Microsoft. How Macs are not good with projectors? Anything? Okay. Cool.
Hold on. Do I actually have? Okay, good. Wow. So this is the Azure Portal. Because I need to grab the public IP for the Salt Master. All right. Quickly. Yeah. Where is it? Here we go. Okay. All right. So this is basically where we're going to SSH into this guy.
So what's already been done is, since it takes a long time to provision VMs, what's already done prior to this demo, which thankfully we did, was we provisioned already these virtual machines. So what Rita's going to do is just SSH into the Salt Master, just to kind of give you a demo of like how to operate with Salt to manage your state.
All right, so as I mentioned earlier, right, so now we're in the master, the Salt Master. So just really quickly, I would like to show you, really quickly to show you like what the Azure configuration looks like. So as I mentioned earlier, you can basically tell Salt Cloud what operating system, what provider you want to use. So whether it's Azure or AWS or DigitalOcean, and what size you want and for your VM, and then what operating system to run it on and what location, right? And then you can also specify what storage account you want to use, network security group, and so on and so forth. And because it has an inheritance aspect to it, so for example, in this case, for my ElasticSearch node, I just basically extend from the previous configuration because I know I want to run a CentOS OS VM. So in this case, I'm inheriting from the previous configuration, and I specify this is the size I want, and this is the disk that I want to create for my data, and then also please run it in East US, and then also the role. So what this does is it basically tells, remember Jason mentioned earlier, grains is a key value store that basically allows us to store system variables. So in this case, I'm basically defining a key called role and then tagging this particular VM for Elasticsearch, so that when I run and apply the configurations, it actually knows, oh, go ahead and apply these changes only for the Elasticsearch nodes. So imagine a scenario you're managing Elasticsearch, MySQL, Redis, Mongo database. So you want to be able to apply changes only to the ones that you want to apply to. So this is why we have this. So last but not least, when I create this configuration for the Elasticsearch slaves and then the Elasticsearch master. So once this is all basically configured, all I need to do is basically just run something like I will need to run Salt Cloud to actually create the VMs, and because that takes some time, and we already previously created that. So once that is done, then those VMs are created with these roles. So what we could do next is literally just do something like this, and that is again telling Salt to install the binaries and configurations on the nodes with this role. So once I run that, it's going to apply all the changes that I want on those VMs. Okay, so once I do this, I now have Elasticsearch installed for the minions, for the Elasticsearch slaves. And then next I will apply the same thing, but for master. All right, so once that's done, then I'm going to come over here. And for those of you that have used Elasticsearch, this is a little cool Chrome extension that allows you to test your Elasticsearch index. And here, this is the public IP of my Elasticsearch master. And as I said earlier, we opened up the port 9200 so that you can actually talk to the search index. And here is where I'm actually going to query the index. And as you can see right now, there's nothing in the index. So next, I'm going to just add some things to the search index, add some tweets, maybe a Facebook post. And then next, when we actually do a get on our search index, as you can see, this is all up and running. So what does all this mean, right? So basically, this is how we are able to take an Elasticsearch formula and then put it on the Salt Cloud, put it on the Salt master, and then apply certain commands through CLI, and then that's how Salt master is able to provision all the nodes from my Elasticsearch cluster and apply all the binaries and all the configurations. And I'm able to do this all with code, right? I did not have to run any commands onto those Elasticsearch nodes at all. I didn't have to SSH. They're all done for me through Salt Cloud. Okay, so let's come back to this. And here, as you can see.
Oh, nice.
Oh, right.
It worked.
We should have just done that in the first place. Okay, so we kind of cover this, right? How how Salt is reading the cloud information, and then we also touch a little bit on this, where you're telling the Salt master here here are the nodes that I want to apply these states to, and each one of these guys is a formula, right? So as Jason mentioned earlier, the wildcard basically says I want Vim on all my VMs, right? And then the web, for the nodes that are tagged as web components, I want to make sure I have Apache, Python, Django, so on and so forth. So with something like this, you can create a configuration just for your application. So imagine you have a web application, right? A tier, a database tier, the service layer, and then the front end. And you can basically do this and define a recipe just for that application. And all you need to do at the end is basically run a SaltStack CLI to apply those changes. So next week, I guess we have the MySQL
Yes. Yeah. So what Rita kind of demonstrated is just kind of defining her own formula for Elasticsearch. And as I mentioned before, SaltStack has a pretty awesome community behind it. Okay, you guys can see this? Okay. Is this the page? Sweet. Okay, so on this GitHub page called SaltStack Formulas, the community has already created these formulas to deploy a variety of set of applications. For instance, let's just take a look at Salt formula. So you can actually use Salt to deploy more Salt masters. But what we're going to demonstrate is kind of how you can just leverage this MySQL formula. So MySQL, I'm just going to grab it. Okay. This is the Salt master.
CD and
CF.
serve Salt.
It's so slow. Okay. All right. So what I'm going to just do is git clone this formula down onto my Salt master. So now I have all the top files, all the SLS files. So we have all the formulas within our Salt master. And then if I don't have any typos, what we're going to do is just restart the Salt master service just to pick up those changes. And then we can deploy it. So what I want to do is called Salt. I want to target just the machines with roles MySQL. I believe it's, actually I have it right there, right? No, roles MySQL. What I want to do is state.highstate. Thank you, Rita. So what this instruction is telling it is doing is I want to just apply my state to just the MySQL machines. This is a live demo, so okay, this is like for realsies.
Go grab the IP for the MySQL database.
Oh, I see.
Yeah. Okay, so because of time, we already ran Salt Cloud already, so those SQL nodes are already up and running. It's just none of the binaries there. So what this is doing is pushing the binaries and installing and running all the scripts. So what we're doing right now is grabbing the public IP of the node that was created for MySQL, so that you can actually see what's actually getting installed, right? Did you get the IP?
Yeah, I got the IP.
Okay.
Now we're just waiting on Salt. So what's Salt? Oh, sweet. Oh my God. I was like a little bit nervous right there. But what Salt just did is it applied that formula. So within that formula, let's kind of go up, scroll all the way up. So it kind of has a diffing knowledge. So it actually is, hey, this is a brand new MySQL thing you want to bring up. So it did everything. Installed some common packages onto that VM, took MySQL, did an apt-get MySQL. And actually, I have in the formula, I've actually defined a certain password and username and created a DB. So it applied that and created those users within MySQL and did it. So do we have a terminal with that?
Yeah.
Is this MySQL?
Can I do? Oh, never mind.
Go for it.
Yeah, you kind of need
Yeah, it's her password.
Oi. All right, cool.
I've completely forgotten the username now.
Root,
thank you. And the password was what I defined.
DevITconf.
Thank you, Rita.
Yes.
Cool.
Database.
Sorry, I can't type. And so we have kind of a MySQL cluster. Yes. Yeah, so as you saw, with SaltStack, with one command, we were able to just bring up MySQL on one of these VMs, create a user, root. Well, actually, root already exists, but we changed this password to devitconf, and then actually create a database called devitconf. So with that, you could actually pass it a schema, and Salt could also just bring up your whole database schema as well. So that really brings us out. It kind of finishes up the demo.
Pretty much.
Let me go back to the PowerPoint. Does it work? Sweet.
Okay, so with that, we hope this is like a good demonstration of like how to use SaltStack and how to use SaltStack for your own infrastructure needs. But specifically also, this is why we exist in the sense that we work with like communities like SaltStack to make sure that you, developer like yourself, you can actually bring any stack of your choice. You shouldn't have to pick, and it should just run whatever you choose to run, whatever platform or framework, or whatever operating system you want to run.
So a quick resource list. So Rita's actually posted a blog post of her experience working with LogDNA and adding the Azure, or improving the Azure support of SaltStack onto that link. Also, that's our team blog, so we do a bunch of other cool stuff. So you can kind of explore our team and what we do there. The SaltStack GitHub repository, the ElasticSearch and MySQL are all on GitHub as well. And Azure ARM templates if you want to do like a quick deploy kind of thing. So all the ARM templates, there's a button there. So you can actually see, if you see something interesting, you can just click the button and it'll deploy whatever the ARM template does.
Oops, sorry.
Oh, okay.
Yeah.
That's kind of it for us. Thanks for bearing with us throughout this whole technical difficulty thing. But
yeah.
And then I think we have some time for questions.
Yeah.
Maybe?
Yeah.
We do?
Despite the 20 minutes?
Let's do 2 questions maybe. And are you guys going to be tomorrow at any of the workshops or not really?
We're debating between learning or exploring Greece. This is our first time here.
Let's have a vote for that.
Everyone has their hands down. What does that mean?
Okay, let's see.
Do you guys have any
question?
questions on SaltStack or Azure in general?
Hello. Thank you very much for your presentation.
Wow.
I have no idea.
Where are you?
Oh, okay.
Oh, hi.
I would like to ask you how we can test with SaltStack. For example, to test infrastructure as code. For example, like Ceph. You can test your infrastructure with SaltStack. How you can do that, if possible?
How you, okay, so we do have a case study out there that you can read the blog on, but also there's a lot of really good documentation on SaltStack's, their own GitHub page. So if you want to just try it out on your own like cloud provider, you could totally do that. If you're interested in how it works on Azure, you know, on the resources page, we also have, you know, a bunch of links that I think will be very helpful. Specifically, like everything we demoed today is on GitHub. So you can totally check out the scripts, check out how we're actually deploying everything.
Was your question of like how do you actually make sure that your scripts
not exactly. For example, with Ceph, you can test your infrastructure as code on your local machine, and you can see how it runs on production, for sure. I didn't know if SaltStack has something like this. You for example, you run your infrastructure in your local machine, and you can see how it will run on production, exactly the code you have written.
Yeah. So like if I'm understanding your question correctly.
You write, for example, like running a unit test, your infrastructure code.
Yeah.
Something like that.
I think innately what you're doing, it's not really code per se. Like you can't really, it's pretty hard to test this functionality just because you are bringing up a new virtual machine. That's one case. Or you are bringing up MySQL. So you could, in theory, run your SaltStack or your infrastructure as code, whether it brings up a VM, brings up MySQL or Elasticsearch. You could do that step, and then you could have a CI pipeline using Jenkins, VSTS, whatever, that could test that your MySQL instance is up. So I don't think there's anything built into the framework to allow that testing, just because the framework doesn't really understand what you want to do, just because you can define formulas in whatever manner you want.
I think one thing is like for the things that you're deploying, like the binary, the scripts, like for Elasticsearch, there's a bunch of things that had to happen, right? So for those specific things, you could totally test that on a VM of your, like just on a single Linux box, or run in a container, right? You can test those scripts first, which is what I did, right? Making sure those scripts actually work, and making sure your Elasticsearch actually runs. And then once you do that, then you can break it apart and then run it on like the master node or the slave node, and just make it into like what SaltStack is looking for, if that helps.
Does that answer? We can't really see the crowd, so I'm not sure if you're nodding yes or like looking really confused.
Yeah, I think he's
okay. Yeah.
We have an okay there.
Yeah, and again, if you're interested in how that's done, check out the GitHub repo. It has like all the scripts there. Cool. Thanks.
Any other questions, comments, concerns?
Anyone else? Yeah, we have a question here in front.
Go for it.
So you mentioned earlier that one of the roles of the master is to hold all the binaries for all your slaves.
Mm-hmm.
Does it have any inherent way to do upgrades? Can you?
Oh, yes.
So you can upgrade parts of your fleet easily? Does it take things down one at a time and all that kind of stuff?
Yeah. So the way so remember how he talked about like Salt disk usage or whatever. There are commands that already come out of the box from Salt that can help you run certain commands. So for example, if you want to know like what is the status of all my nodes, what version of something am I running? So you can query that, and if you want to just do a rolling update, you can always create a state. Remember earlier how we were actually creating those configurations? You can once you've done that, you can just add that to your top file, and then you can again run the salt command to apply the new state to those VMs.
And rolling across your whole
And rolling
thing.
across. Like it always knows, if you have the state there in the top file, the top file will think, okay, that's the state you want to get to. Does that help?
Yeah.
Okay.
Thank you guys, you are truly awesome.
Thank you.